Hello everyone, this is class number 25. Today we are going to discuss about nested loop. This class is the third class of total 5 classes on loop. In last 2 classes we already discussed about for loop, while loop and do while loop. Today we are going to discuss about the nested form of those 3 loops: for loop, while loop and do while loop. So welcome to Classroom Computer. Let's start. At first let's understand what is nested loop. Nested loop means one total complete loop inside another loop. We know that loop means iteration. So a nested loop creates a hierarchy of iteration. The outer loop executes after the successful complete iteration of the inner loop. One more thing, that it is not necessary that every loop within a nested loop structure be the same type. You can nest different types of loop within each other. Like a for loop can be nested within a do while, or a while within a for loop. Anyone. Nested loop looks something like this: a for loop within a for loop, or a while loop within a while loop, or a do while loop within a do while loop, or a while loop within a for loop, or a do while loop within a while loop, or a while loop within a for loop. Anything, any combination. This, it can be this, it can be this, or this. It can be a for loop within a for loop, or it can be a while loop within a while loop, or a do while loop within a do while loop, or a for loop within a do while loop, or a while loop within a for loop. Any type of combination within those 3 loops. Let's understand the mechanism of nested loop very briefly. Compare the nested loop with an analog clock. Here in this nested loop, total 3 loops are here: a for within a for within another for. You can add any number of loop within a loop. Here compare the outermost for loop with the hour hand of this clock. Compare the middle for loop with the minute hand of this clock, and the innermost for loop with the second hand of this clock. The mechanism of this type of clock is when the second hand completes a cycle, that means a 60 seconds, then the minute hand increase with +1. Same when the minute hand complete one cycle of 60 minutes, then hour hand of the clock increase with +1. Same in nested loop. For every complete iteration of innermost loop, the number of iteration of middle loop increased with +1, and for every complete iteration of inner middle loop, the number of iteration of outermost loop is increased with +1. Let's understand an example. Here is a for loop. In this picture you can see 2 loops are here. The outer and the inner loop both iterates 3 times. Here for each iteration of outer loop, the inner loop iterates 3 times. Here you can see the outer loop iterate 3 times and the inner loop iterate 3 times. Then the total number of iteration is 3 into 3 equals to 9. Let's see the nested loop very briefly. Look at this table. 3 columns are here: iteration number, value of I and value of j. This variable I is dedicated for the outer loop and the variable j is dedicated for the inner loop. Let's understand this table. The first row is iteration number 1. If you see this loop structure at the time of initialization, it initializes with 1, both of them, I and j. So the value of I is 1. Next part, the comparison part. Here I less than equals to 3. The value of I is 1. So I less than equals to 3 is true. So the flow goes into the loop. And here comes the inner loop. At first j equals to 1. The initialization part of inner loop, Next, control goes to j less than equals to 3. Now the value of j is 1. So the condition is true. So the control enter into the inner loop body and system out print j execute. That means this line print the value of j. Look at this print. This is print, not println. That means that the every print statement, the every value of j print in a same line. So the new value of, after that the updation part, that means j increase with +1, so the new value of j is 2. After that the body of loop of inner loop ends. So the control goes to the starting part of the inner loop. Now this is the second iteration of inner loop. So the execution starts from comparison part, j less than equals to 3. The value of j is 2, so the condition is true, so the control goes into the body of loop and the body of loop print the value of j, which is 2. Then 2 comes just after the previous one in same line, because here print statement is system out print, not println. So cursor stay in that same line. So after print the value of j, which is 2, the value of j will update with +1. So the new value of j is 2 + 1, which is 3. After that control goes to the starting part of inner loop. Here j less than equals to 3, the value of j is 3. So the comparison is true. So the control goes inside the loop body and print the value of j, which is 3 in same line, previous two output. After that the value of j update with +1 and the new value of j is 4. The control goes to starting point again, but here j less than equals to 3 is not true with the new value of j, which is 4. So this time the condition is false. For this reason the control goes the line outside of inner loop, which is System.out.println. That means only cursor moves to second line. Look, this inner loop and System.out.println both are the body of outer loop. So at the end of the loop the value of I will be updated with +1 here after System.out.println. And after that the control moves to here. Is I less than equals to 3, the new value of I is 2. Yes, this condition is true. And the control again moves inside this inner loop for j equals to 1, j less than equals to 3, j ++. Now see the table here. Here is the value of I, which is 1, 1, 1, and the value of j is 1, 2, 3. After that the value of I is 2, and for every value of I is 2, the inner loop iterates from the j's value 1, 2, 3, and after that I increase with +1, so the new value of I is 3, and the condition is I less than equals to 3, so it again goes inside the body of loop, and the body of loop contains this inner loop. So again the value of j 1, 2, 3 print. And here is the next line statement. That means every after 1, 2, 3 the cursor moves to the next line. So the output is looking something like that. This 1, 2, 3, 1, 2, 3, 1, 2, 3. You can give a single blank space after every j value in print statement. So this is the nested loop. Here is the question. This is the sum of the factorial of first n natural numbers. So here is the calculation of the sum. The loop is running for n times. Let the value of n is 4. So here is the two loop part. The multiplication of the inner loop and the addition thing execute through outer loop. Here is the total program code. Here you can see sum and product as long type of variable. Why? This is very important. Be careful about it, because the sum or the product can exceed the limit of integer type variable. In those cases, you should declare those variables with long, because factorial of a number where the series ends with n, that means the ends with some value which is given by user. If user give a 3-digit number, then the sum of this series can exceed the range of an integer variable. It can overflow. So in those cases, you should declare those two variables, sum and product, as a long data type variable. Let's see the program code for the loop. This is a nested while loop. A while loop inside another while loop. The outer loop calculate the sum of each factorial and the inner loop calculate the factorial. Here, before entering the loop, I and j both are initialized by 1. Let's explain the loop. The value of n is taken from user. The value of n is 4 here. Now if I less than equals to n, the control enters in the outer loop body. Now the inner loop calculate the factorial of the value stored in I. This is the loop structure, and here is the table. Assume the value of n is 4. So now the program calculate 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. In first row, initialized value of all variable written here, like I, j, product. Those three are initialized with 1 and the sum initialized with 0. Now the first iteration, the value of I is 1 here. So in inner loop, j less than equals to I. This is also true because I and j both are same. The value of product is here 1 because the product initialized with 1. So it's 1 into 1, 1. After that, j plus plus. So the new value of j is 2. Now j less than equals to I is not true. So control goes to next line after the inner loop. Here j is initialized with 1. I increase with plus 1. So the new value of I is 2. Sum equals to sum plus product. The sum was initialized with 0. So it's 0 plus 1, 1. After that, the product also initialized with 1. Next, the control goes to the checking part of outer loop. New value of I is 2 now, which is still less than equals to n because the value of n is 4. So it goes into the loop. Now look at this table. Here iteration number 2 and 3 both calculate the factorial of 2 and add the factorial of 2 with the previous value of sum. Iteration number 4, 5 and 6 and 7 calculate the factorial of I. New value of I is here 3 and add with the previous value of sum. So it's 3 plus 6, 9. And after that, the iteration number 8, 9, 10, 11, 12, all of them calculate the factorial of 4 and add the value of the factorial of 4 which is stored in product variable with the previous value of sum. So it's 9 plus 24, 33. After that, look, the value of I is 5. So this line is not true, false. So control goes outside of those two loops and print the value of sum. Here is the output. I can see you the program code in BlueJ window also. Here is the total program code. If I do the same program with do while loop, then it looks like that. Everything is same, only I put comparison part, this while and this while, at the end of each loop. Here is the comparison part. You can see the difference, and this is the output of do while loop. Same. Let's discuss another program checking for Krishnamurty number. You can call it strong number, special number, or Peterson number also. Here is the logic behind it. It is a positive, sorry, two p's are there, that's my mistake, typing mistake. please ignore. It is a positive integer where the sum of the factorials of the individual digits equal to the number itself. Here is an example, 145, because factorial of 1 plus factorial of 4 plus factorial of 5 is 145. Let's see the program code. Here is the program code. In the program, we have to extract each digit like 1, 4 and 5 from 145 and calculate the factorial of them individually, and then at last add those 3 factorials in case of a 3-digit number and check the sum of the factorial of 3 digits with the main number. This is a loop. This is a decision making and loop part of the program. One more thing, whenever you have to break the number given by the user and do something, and after that check the answer with the given number, then you have to copy the number in a different variable, because whenever you break the number you actually lose the number. Okay, you actually destroy the number, so you have to have a copy of that number before breaking it. So here this is a loop part. I took the number from user and stored it in a variable name n, and I copy that number with a temp variable within a temp variable. While temp greater than equals to 0, here x equals to temp% 10. That means this line actually extract the rightmost digit in temp. In case of 145, it's 5. So the value of x is 5. After that, this inner for loop actually calculate the factorial of 5. And after that, sum, we add the factorial of 5 with the sum, which is initialized with 0. And after that, we have to initialize the fact variable with 1, because in next iteration it will calculate the next digit of that number stored in temp. And after that, it's temp by 10. In case of 145 is 145 by 10. So it's actually 14.5, but temp is an integer variable, so it never stored any fractional number, so it ignores 0.5. So 145 becomes 14 only in this line, temp equals to temp by 10. Now this control goes to while again. It's temp greater than 0, yes. So it goes for here, so it goes here, x. So now it extract 4, and these actually calculate the factorial of 4 in case of 145, because I took the example 145. Then sum equals to sum plus facts, so it's 5 factorial plus 4 factorial, and then temp equals to temp by 10, so the new value of temp is 1. Then control goes here. Is 1 greater than 0? Yes. So now it's x equals to 1. This factorial actually calculate the factorial of 1 in case of 145, and the now sum is 5 factorial plus 4 factorial plus 1 factorial, and the temp is 0. Now the control goes here, 0 greater than 0, no. Now this condition is not true, because I didn't write any equal sign here. It's only greater than, not greater than equal. So control jump here. If sum equals to n, n is the previous number taken from user, then it's a Krishnamurty number or strong number or special number or Peterson number. Otherwise, this is not a Krishnamurty number or strong number or special number or Peterson number. Look one thing, here I also write if n greater than 0. Why? Because the question says it is a positive integer. So you have to check whenever your question write something like that, it's a negative thing, it's a positive thing, then you have to check the positivity or negativity of that number. In program, if n greater than 0, then This program will do all those things, checking of Krishnamurty number, factorial, summation, etc. etc. Otherwise, it actually goes here if the value of n is not greater than 0. This is the table. All those red marks 6, 5, 2 indicates that the condition in this loop is not true here. That's it. You can compare all my theory, whatever I said, with this table. Whenever you want to understand nested loop or loop, draw a table. It's a very good practice. Then you can actually divide each iteration and understand each iteration separately. Now come to a comparison or differences between those three loops: for loop, while loop and do loop. In case of for loop and while loop, the checking is happen at the beginning of the loop. So it's both those two loops are entry control loop. But in case of do while loop, the checking situated at the end of the loop. So it's a exit control loop. For that reason also, if the condition is false, then loop body not execute for while and for loop. But in case of do while loop, if the condition is false, in that case also, the loop body will execute at least one time. So this is actually defining the point number 3. In case of for loop, the number of iteration is known. And in case of while loop and do while loop, number of iteration is unknown. That doesn't mean that while loop and do while loop not works for known number of iteration. Those while loop and do while loop both are works for known number of iteration and unknown number of iteration. The header contains initialization, test condition and update all parts. You can see in the syntax of for loop, those three parts are separated with semicolon, but in case of while loop and do while loop, the header, and in case of do while loop, the footer, not the header, footer contains only test condition part. So here is the end of today's class. If you like this class, then please hit on the like button and subscribe my channel. If you have any question or doubt, feel free to write those question or doubt in comment, or you can mail me. I will answer you sure. Thanks for watching and keep learning. Bye.